We're going to be discussing the mathematics of finance. So looking at if you borrow money, what's going to happen? How much do you owe? Those types of things, because whenever we borrow money, we are going to have to pay interest because we are using a service in which we are borrowing. So the first thing we're going to look at specifically are the compound interest formulas. There's what's called simple interest. Simple interest is where it is just an interest rate charged on the principal. However, there's also what we have is compound interest, where it's the interest charged based on the original principal plus interest on the accrued interest. So the first formula that you will have with compound interest, this is if you are in the situation where it's compounded in K times per year. The first one is A equals P times 1 plus R over K to the power of KT. Okay, so let's talk about what these different things are. P represents the principal, otherwise known as the deposit or initial. R represents the rate. K, in this situation, is number of times compounded. And T is time in years. So again, this one is if you're compounding several times in a year. So for instance, if I'm compounding monthly, my K would be 12. If I'm compounding quarterly, it would be 4. Just depends on those different things. Then we have a different type of compound if it's compounded continuously, which is in the form of A equals PERT, where again, P is your principal, or your initial. E is the number E. Okay, so don't think of that as a variable. E is the number E, as in 2.718. R is still your rate, and T is still your time in years. Okay, so those are the two different compound interest formulas that we'll be looking at, and it's just based on the time frame. So for instance, let's say that Derek invests $15,000 into an account at 2.75%. How much money would be left after 10 years if the account is compounded quarterly? How much would be left, same numbers, if it was compounded continuously? So let's look at the quarterly one first. So I'm just going to use that formula. So I have A equals 15,000 is my P. My R is my rate of 0.0275. K in this situation is compounded quarterly, so that would be a 4. And then in my exponent spot, I'd have 4 times 10. So the nice thing with this question specifically is you're plugging all your information into a formula and you're just calculating, which is nice. So be careful on when you're doing your exponent that this right here, if you're using your calculator, might need to be in parentheses to make sure that it doesn't take it to the power 4 and then multiply your answer by 10. So just something to look at. So after plugging this information into the calculator, you get $19,729.39. Now remember, think about this. It might round down to 38. Thinking about investments and whether or not your bank is going to round up or down, depending on which way you're going. But if you're gaining money, they're probably going to round down. But if you're paying them money, they'll round that up. So quarterly is $19,729.39. If you look at continuous, again, we'll have that different formula. Because of our time frame, it's a little bit different, which is fine. So our P is our 15,000. E is the number E. Our rate is at 0.275, and that'll be times our value, or our time there, of 10. Sorry, just doing my quick calculations here. and we would get $19,747.96. Now, some of you out there might be looking at this and saying, okay, well, between quarterly and continuously, there really wasn't a whole lot of money there. And you would be right in this situation. If you're looking at this, your dollar amount is the same, your rate's the same, your time's the same, but your compounding is only 4 versus continuous. If your years went up to, say, 50, then you're going to see a bigger difference between quarterly and continuously because it's a longer period of time where that compounding is just going to keep going. Okay, so I know it doesn't look like a lot right now, but over time it really would be. We have a couple different vocab and formulas to talk about here on this one. So we have the annual percentage yield. What you're doing with the annual percentage yield is you are comparing investments. You're comparing investments in the looking at the percentage rate, whether it's compounded annually or not, and determining where your what rate would need to be to make it so that they're the same. So you could be looking at, I'm going to look at this IRA that has compounded quarterly. We're at a rate of 2.5, where this one is compounded monthly at a rate of 1.6. You know, something like that, where you're comparing those investments and figuring out what is your best situation. Annuity is a sequence of equal periodic payments. So basically like a monthly payment when you have to pay your bills, this is your annuity. So just a phrase that you'll hear in financial, jargon type of stuff. All right, so future value of annuity. This is talking about where your investment or loan might be going in terms of how much you're projecting money-wise what it's going to be in the future. So this formula is in the form of our future value equals R, and I'll explain what these are, times 1 plus I to the power of n minus 1 over I. Okay, and in this situation, the R is your dollars. Your I is your interest rate in terms of the compounding period. N is going to be, that's going to be your number of payments. And we'll look at a specific situation where we'll kind of talk about what is the R, what's the I, what's the N. It'll make it a little bit easier. But for right now, this is just our formula. So future value is the projected, which obviously makes sense, it's future. Present value. This one obviously is going to be money that is put into an annuity at the present value. So we have PV equals R times 1 minus 1 plus I to the power of negative n, and that's all divided by I, where again the R is your dollar amount, I is your interest rate per compound, and N is number of payments. Okay. So, example 2. Tracy contributes $200 each month into her mutual fund. If her investments earn 5.25% annual interest compounded monthly, what will be the value of Tracy's annuity in 20 years? So, we're talking in 20 years. So we're talking a future value. So we're going to use that formula. And we're going to calculate her annuity in 20 years. So her R value, her dollars, she's contributing $200 each month. Okay, let me make that a little bit bigger. Now, her interest rate. This is where it gets, remember, interest rate is in terms of the number of compounds in a year. So her interest rate is 0.0525 divided by, it's compounded monthly, so that would be divided by 12. The N represents the number of compounds or equal payments, number of payments. So she's having this for 20 years and it's compounding monthly. So this power is going to be 20 times 12. Okay, and then we have that minus 1, and that information is all divided by that 0.0525 divided by 12. Now, the nice thing with this, all we're doing is plugging our information into our formula and you're just calculating. So I'm going to go ahead and do that, plug it in, and you would get the future value is $84,622.36. Future value investment. So contributing $200 each month for 20 years is in an investment is going to gain her $84,000. That's a pretty good chunk of change, and that's something to look at for future investments in terms of like retirement. Last but not least, let's talk about present value. Scott recently bought a house that cost $215,000. What are the monthly payments to a 15-year loan with a $30,000 down payment if the annual interest rate, the APR, is 3.28%? So this is important because we're talking about mortgages, and a lot of people have a misconception of what their monthly payment is and whether or not they can afford this. So looking at our formula, this one's just set up a little bit differently because we already know what the present value is of the house because you bought it for so much and you're taking a down payment off. But the R is what we're trying to figure out because that's the monthly payment. Okay, so a little bit different to the other one there, because we're trying to find something else. So if it's $215,000, we're taking away $30,000. So this is actually $185,000, and we're trying to find that R value. Again, I'm plugging in the information I know. And we're going to figure out, so we're talking a 15-year period times 12. And that's over that 0.0328 divided by 12. So thinking about this in terms of mathematical, you're just manipulating your equation a little bit. So if you're looking at this, you have division. So you're going to take this. It's being divided by, so you're actually going to multiply by that. So you're going to take 185,000 times that 0.0328 divided by 12, and then that's going to equal everything else that was left over. This way, we are getting rid of that fraction, which is going to make life so much easier. So in this situation, we now are trying to get R by itself, so we have that left side, and we're going to divide it by that right side. Now, when you type this in, you might actually want to simplify a little bit of this before you get into the big meat of trying to type all this in at once. And I'm just saying that as just helping yourself out before having some calculation errors. So this whole equation is going to figure out my monthly payment or my mortgage payment each month. If you calculate this, it's going to end up being $1,302.64 a month that you're paying on that mortgage. So even though you bought a house for $215,000, you put a big chunk of change down, but realistically, your monthly payment is quite a bit. So that's something to think about, and you could then look at the projected value and figure out, okay, well, how much am I paying in interest alone over the whole life of the loan? And it's quite a bit. So this is something to think about when you're looking at investments or you're looking at borrowing money in terms of loans.